Good evening, ladies and gentlemen, good morning, colleagues and fellow scientists. Welcome to the Geological Society of America's annual Arthur Day Medal Presentation Symposium. My name is Paul Schonecker. As the Professor of Geophysics at Caltech, and having been a past recipient of the Arthur Day Medal in 1994, I've been given the honor, on behalf of the Geological Society of America, to present this year's Arthur Day Medal winner, Professor Stephen D. Miller. A little bit about Arthur Lewis Day. He was a physicist whose career extended from the beginnings of World War I into the nuclear age. With the development of radioactive mining at the bottom of the ocean, and his contributions also include studies of the Earth's crust and earthquakes. After surveying earthquake zones in Southern California, he developed principal studies in geology along the fault zones, surface displacement, and continuous seismology observations, resulting in subsequent development of instrumentation to observe earthquakes of a magnitude and scope beyond anything previously attempted. The Arthur Day Medal was established in 1948 by Day himself. It was his intent to recognize outstanding achievements and inspire further efforts, and to recognize individual contributions in the field of geophysics and environmental sciences. The Arthur Day Medal is awarded by the Geological Society of America to an individual for outstanding distinction in contributing to geological knowledge through the application of physics and chemistry to the solution of geological problems. A little bit about tonight's winner. Professor Stephen D. Miller, I've known for many years now. He and I attended MIT together and shared many projects. There was never any doubt he would develop into one of the top scientists at MIT with his fortitude, resilience, and will to succeed. And we did have a lot of fun. We did go up the lab once. Other than that, things were pretty normal. There were many times when I had thought to give up on something, but Stephen, always in good cheer, would with confidence, self-reliance, and kindly reassurance, keep us on course and conclude the project. Those were good experiences for me and helped make possible my own pathway to professorship. Stephen Miller, tonight's honored guest, a professor of organic chemistry at the Radiological and Environmental Sciences Lab in Idaho Falls, Idaho, whom I've known for many years, has developed what may be the single most significant contribution to the environmental sciences in the history of mankind. A device that effectively converts and removes greenhouse gases in the atmosphere, which has become the inspiration for this award tonight, the Arthur Day Medal. With the endorsement of the Geological Society of America, whose purposes are to advance geosciences and to enhance the professional growth of its members, and to promote the geosciences in the service of humankind, has indeed chosen wisely, and I'm proud to be asked to present this award on their behalf, while I'm certain this is the first of many awards to present it to you and to your team. Please give a warm welcome to Professor Stephen Miller.
Thank you, Professor Paul Schonecker. You've been a great friend since our years at MIT. The few projects that I do remember that we worked on was the theoretical effects of climate change. various other projects dealing with the absorption of infrared radiation. I would also like to thank the Geological Society of America for this prestigious award. And also thank you to the Radiological and Environmental Science Laboratory for the support and funding and the help that helped us get to this point. Another thanks goes to my colleagues for their encouraging support and hard work. Without their help, we would not have would be receiving this award tonight. This award means a lot to me. After working on the device for over 8 years, it feels good to be recognized for this accomplishment. Receiving this award brings me hope that this device and the research behind it will be used towards reversing the effects of climate change. The device works on the principle of converting carbon dioxide, one of the primary greenhouse gases, into oxygen, ozone, and nitrogen. This is a three-part process. First, using the proton generator, we can remove oxygen atoms. Second, particle divergence atomizer. Accelerates the transmutation process of converting carbon into nitrogen from the normal speed of 5,780 after last year. Into a mere nanoseconds. Third, using the extreme heated plasma rate, we have been able to bond the now free-flowing electrons into the oxygen atoms, creating the additional benefit of ozone replenishing to the upper magnetosphere. The device is called the Miller Thermophotometric Particle Atomizer, MTPPA. The initial experiments and the field trials, we have been able to achieve thermodynamic stability thereby creating controlled sustained chain reaction. It's such an honor for me and my colleagues, and me to be recognized for this achievement. We are humbled by being accepted into this group of exceptional people that have received this award in the past. Thank you again to Professor Paul Schleicher and the Geological Society and the Radiological Environmental Science Laboratory.